morning, you guys. This is the last part of chapter 8. We are going to be solving inequalities, and I really like this section because it is very similar to solving equations. I also kind of like solving inequalities. I hope that you guys see that this is very much a review of things that we've already done this year. And so, if you remember, it says, well, first, you can solve inequalities the same way that you solve equations. But to solve equations, we used what was called inverse operations. And those kind of undid each other because they were the opposites of each other. So adding and subtracting were the opposites of each other, multiplying and dividing were the opposites, and they like canceled each other out. And so that's basically what it's saying down here. But if you remember how to solve an equation, it's the same idea for an inequality. The only difference is that instead of the equal sign, now like on this one, there's a greater than sign. And so where the sign is, that's where it kind of splits in half. Remember that you want to keep the two sides balanced. But at the end of this, you want the final answer to say x is greater than, because the sign says the same, and then whatever the final answer is. So your goal here is to get x by itself. And this one, we want x on the left by itself. And so the only way to get rid of this minus 3 is by doing the inverse or the opposite. So instead of minus 3, we're going to add 3. Whatever you do to one side, you do to the other. And so these cancel out, so that all that's left is x. 1 plus 3 is 4. And so the solution to this inequality is x is greater than 4. And because, like yesterday, we said that that could be any number greater than 4. It could be 5, 6, 7, 8, 8.5, a million. You can't list out every single possibility. I'm kind of out of room, but we're going to do a little mini graph right here. And what this is saying is that any number that is greater than 4, if you put it back into the original inequality, it will make that statement true. And so let's do the graph real quick. It says greater than 4, so that does not include 4, so it's an open dot, it's not colored in. And you're drawing an arrow showing greater than, which is pointing to the right. And so what I meant earlier was any number greater than 4 will make the statement true. So pick any number that's greater than 4. And if you say that that's equal to x, like if I choose 6, if I do 6 minus 3 greater than 1, does this work? Is 3 greater than 1? Yes. So that's true. So it's saying that x can be any number that's greater than 4. If you chose a number less than 4, it would not work. That statement would not be true. So come over to B. Try this one. That's a 5. 15 is greater than or equal to 6 plus h. So split your inequality in half. You want to get h alone. So instead of plus 6, I want to subtract 6. 15 minus 6 is 9. Symbol stays the same. And then this side, the 6's cancel out. So 9 is greater than or equal to h. And so if you kind of think about this, again, I want to graph h. And so this includes 9. But when I say 9 is less than h, what I'm really saying is, 9 is greater than h, what I'm really saying is h is any number or equal to less than 9. Okay, so you need both parts. You need the graph and the solution. All right, you guys pause here, try the try-it questions real quick, and then we'll do some multiplying and dividing. All right, for number 1, I'm just gonna split it like that. The opposite of -2 is adding 2 to both sides. So these cancel out, and x is less than 3. To graph that, you can make your number line bigger if you want. I only do the 3 numbers so that I can see bigger than 3, less than 3. This is not colored in because it does not include 3, and the arrow, oh my gosh, that was a mistake. 3 plus 2 is not 3. Let's try again. 3 plus 2 should be 5. The solution should be x is less than 5. Okay, so anyway, let's try again. So x is less than 5. The dot is not colored in because it doesn't include 5, and it is pointing to the left because it's less than. My goodness. Okay, next. You add 1 to both sides because the opposite of minus is plus. These cancel. 10 plus 1 is 11, greater than or equal to z. Draw a little number line. And then the dot here is colored in because it includes 11. So it says 11 is greater than z. What this really is saying is z, though, is less than or equal to 11. Last one, you're going to subtract 2 both sides. So y greater than or equal to 15. And so I don't know if you've noticed this, but one trick that I remember learning is that if the variable is written first, like on this one, y is greater than or equal to 15, the dot's colored in, but the greater than sign makes kind of like a point or an arrow. It's pointing in the direction that you shade, as long as it's written as like y greater than 15. On number 2, when it's backwards, the arrow is pointing in the opposite direction that you shade. Okay, so we're going to move on to multiplying and dividing. It is the same concept, except now we're doing multiplying and dividing. And so think back to equations again. This one says x over 5, which means x divided by 5 is less than 2. Okay, so split your inequality in half. The less than sign will stay the same. You want it at the end to say x is less than whatever your answer is. And so that it says divided by 5. The opposite of that would be multiplying by 5. So show me multiplying 5 on both sides. These cancel out, and then 2 times 5 is 10. So the solution is that x is less than 10. The dot is open because it's not included. Less than is pointing to the left. All right, letter B. Solve for n greater than or equal to 32. So remember that when the number and the variable are right next to each other, the number is called a coefficient, but that means they're being multiplied together. So the opposite of times 4, be divided by 4. Those will cancel out. So you're left with n is greater than or equal to 8. And when we graph that, you get 8. You want numbers that are greater than or equal to 8. So 8 is included, it gets colored in. Greater than is pointing to the right. All right, pause here, try 4, 5, and 6. Okay, number 4, p divided by 3 is greater than or equal to 6. Opposite of divide is times 3. P is greater than or equal to 6. The graph should look like this, colored in dot because it includes 6, pointing to the right. My graphs are getting smaller each time. Number 5. S divided by 7 is what that really says. So the opposite of divided by 7 would be times 7. 1 times 7 is 7. And then you would say less than S. So 7 is less than S. That means that S is really greater than 7. And then the last one, 11k, 11 times k. So divide by 11. You are left with k less than or equal to 33 divided by 11 is 3. And then dot colored in because 3 is included and we want less than, so we are going to the left. Okay, next we are going to try incorporating fractions. These really aren't more difficult, they're just, when you say a fraction, I know you freak out just because it looks different, but this says 2x over 3. And so if I were you, if you see something like this, I would just rewrite it so it doesn't look as scary. This really says 2/3 x, or 2/3 times x, and then less than, oh my goodness, okay, less than or equal to 4. And so what you're going to have to do now is you're going to, instead of 2/3 times x, you want to divide by 2/3. You can do that. So if I were you, I personally don't want to do that in my head. I know those will cancel out. I know the sign will be the same. So what you need to do, maybe probably off to the side, is 4 divided by 2/3. So if you remember, when you divide fractions, we keep the first one, flip the second one, and we change to multiply. So keep the first one the same, flip the second one upside down, change to multiplying. When you flip the second fraction, that's called the reciprocal. That's why it says using the reciprocal. When you multiply fractions, you multiply straight across, so 4 times 3 is 12, 1 times 2 is 2. You should see that can be reduced. 12 divided by 2 is just 6. So the final solution is x less than or equal to 6 on a graph. You want to include 6 with the colored in dot, less than going to the left. Okay, so practice, really I think the only one that needs to be rewritten is number 9, but try dividing fractions now. So 3 over 2 times m. So opposite of times 3 over 2 would be divided by 3 over 2. This side will cancel. So I want it to say m is greater than something. So now you're doing 1 divided by 3 over 2. So keep the first fraction, change to multiplying, flip the second one upside down. This becomes 1 times 2 is 2, 1 times 3 is 3, so 2/3. So the solution is m is greater than 2/3. The graph, which I am going to squeeze in here, 2/3 would be, 1 above would be 3/3, which is just 1. 1 below would be 1/3. So I want greater than, so my graph would be like that. Number 8. 3/5 times q. So the opposite would be divided by 3/5. So q is going to be greater than or equal to something. I'm running out of room quickly, but 6 divided by 3/5 would be 6 over 1 times 5 over 3. 6 times 5 is 30. 1 times 3 is 3. 30 over 3 is just 10. So q is less than or equal to 10. The graph would look like this. The dot is colored in because it's included. Less than, be pointing to the left. And then the last one of these is 5 is greater than 5t over 6. So if you rewrite this, so it says 5 over 6 times t. It'll look like the other ones. So the opposite of this, oops, would be to divide. Five divided by 5/6. 5 divided by 5/6. So this becomes 5 over 1 times 6 over 5. 5 times 6 is 30. 1 times 5 is 5. 30 divided by 5 is 6. So the graph would look like this. So it says 6 is greater than t, which means that t is less than 6. Okay, so that was solving an inequality. I know that was a lot of writing, but the fraction ones really aren't any different than just plain multiplying or dividing. I think that I'm going to need to erase those because I'm going to run out of room. So the last two, let me erase this, but the last two, number 10 says a one-way bus ride costs $1.75. A 30-day bus pass costs $42. What is going on? Oh. That should say pass. When is a 30-day pass a better deal? The 30-day pass. So I think we did one like this last time, but we're gonna have to write an inequality, I believe. And so what it's saying is for one bus ride, you pay $1.75. If you know you're going to ride the bus multiple times, you can get a 30-day pass for $42, which, depending on how many times you ride the bus during that time, it should be cheaper. And so they're saying that for every time you ride, so let's do R for ride. Every time you ride, you're going to multiply by $1.75. So 1.75 times R. And you want to see when that's going to be a better deal, so greater than the $42. And to figure out exactly how many times you would need to ride now, you would solve that. So you're going to divide by 1.75, divide by 1.75. I'm going to do my division up here for you. So to divide decimals, remember to move your decimal point 2 spots. Add some placeholders. You can check if you want. I'm just going to tell you that 24, or it goes in 24 times exactly. If you really do 175 times 24, you get 4,200. So if you divide, these will cancel out. So R has to be greater than 24. What that is saying is you need to ride the bus more than 24 times for the bus pass to be a better deal. Okay, number 11, a small pizza costs $4.50. A salad costs $3.75. There is a free delivery for orders of $40 or more. You plan to buy 2 small pizzas and 4 salads. Write and solve an inequality to find the additional amount you can spend to get a free delivery. And so right here, when it says $40 or more, that means you can pay $40 exactly or more than that and you'll get the free delivery. So first, I guess you need to figure out how much you're spending on pizza and salad. So a pizza is $4.50. You're going to buy 2 of them. So $4.50 times 2 is $9. And you're going to buy 4 salads. That's $15. So if you add those, you will end up spending $24 on pizza and salads. And so to write an inequality, what they're saying is you're going to spend $24 plus however much the additional amount you need to spend. So the additional amount I'm going to say is X plus the 24 on pizza and salad. I want the free delivery, which is $40 or more, so it can be greater than or equal to $40. Now I need to figure out how much I actually need to spend. So solve and figure out what x is. If you do 40 minus 24, you should get 16. So you need to spend a number or an amount that is greater than or equal to $16 to get the free delivery. Alright, that is the end of lesson 8. Let me know if you guys have any questions. Thank you for watching.